So, in the last lecture, I have obtained the terms of variation in internal work done. So, in there we see that there are number of terms, the terms like this nxx comma x del u naught, underlined terms, these terms will go to the contribution towards the boundary, and the terms like this whole derivative of x or the whole derivative of y will be on a line integral, or in general term if you say that is the derivative and this area is integration 0 to x a on 0 to b. So, if you take the integration along x axis, so it will be integration remains along y direction, and if you integrate along y direction it will remain integration along x direction. So, these terms will contribute or will go to the line integrals, but the underlined terms will go to area. So, in this slide I have just collected the terms, or I would like to say the coefficients of del u naught which contribute on a area. Similarly, the coefficients of del v naught and then the coefficients of del w naught. Basically, we have three primary variables u naught, v naught and w naught. Similarly, we have three variations del u naught, del v naught, del w naught. So, the terms like this, these are basically non-linear terms. Contribution due to non-linear. So, if you do not consider the non-linearity, so these terms will vanish. So, you will have only mx double derivative of x, my double derivative of y, mxy mixed derivative of xy, this contribution from the internal work done. Similarly, the rest of the terms will contribute over the boundaries. So, I have used the Gauss theorem that if you have an equation like this nxx del u naught and this is a. So, using the Gauss theorem we can say that it will be on a line integration and derivative becomes nx cosine vector of that d gamma. So, it is the standard theorem of mathematics. The purpose I can directly integrate and put it that along the y direction. The purpose of writing like this, that later on if we evaluate in a general sense, that suppose you have a plate, now just like this, or maybe some you cut that, then you have a normal and shear direction. So, there you will put normal x, normal along y and shear and so on. So, this will help to develop a general formulation. So, wherever we have a derivative x, it will be nx, whenever we have a derivative y, we will replace by ny. So, no need to afraid, you just put it systematically or consistently nx, ny, nz. The concept behind this, or in a Gauss theorem, if any something is I, then dA, then it will be curve ni and d gamma. So, we are following the same. Now, the contribution by the external work or the external field. So, let us say a plate where this is your x axis, this is your y axis, this is your z axis. First we talk about top surface and bottom surface of the plate. Let us see at the top surface we are applying only a qz along that direction, pressure. Similarly, we can also apply the shear forces like along x direction qx, along y direction qy. But most of the theories you will find that we do not take Qx and Qy, the shear forces. But from manufacturing point of view, there are some cases where at the top surface shear force is applied. Then you have to consider this. But 90% theories which we are going to develop in this field, we consider that shear stresses are 0, that there is no shear traction applied at top and bottom. So, Qz1 is nothing but applied pressure at the bottom of the plate. Here it should be Qz2 is pressure applied at the top of the plate, 1 as the bottom, 2 as the top. And then the deflection, see, minus h by 2 and plus h by 2, that location. For our present case, del W is a constant throughout the thickness, it is not changing. So, ultimately this leads to only del W naught, whether you take at the reference surface or you take at the top of the surface or bottom of the plate, it remains del W naught. So, Qz1 del W naught is work done by the bottom pressure and Qz naught del W2 is work done by the top pressure. Now, these are the faces. What? You see, I am putting here something and some. We have now 4 edges, one x0 to xa and another is y0 to yb. So, that is why we have written in journal form sigma nn applied traction boundaries at these 4 edges. So, sigma nn and through displacement del un sigma ns del us sigma nz del W naught. So, I am going to explain what are these. Let us say you are talking about this face. So, the normal direction of this face is this x. So, we will get sigma xx of hat, and then the shear direction of is this sigma xy of hat, and then nz sigma xz. Are you getting that? X is telling you the normal direction of this face, then sigma xx, xy and xz. So, along this direction, what is the displacement? Del u naught. Along this direction, displacement is del v naught. Along this direction, displacement in del W naught. So, del un for a specific case, if you are talking about this edge, it becomes del u naught. If we are telling about this edge, so the normal direction outward will be y direction. So, it will be sigma yy, shear will be x. So, accordingly, so this is a journal formulation. So, we have written the boundary in a journal sense, it may be along x axis or it may be along y axis, thickness remain minus h by 2 to plus h by 2, and the special purpose putting a hat. So, hat shows you that it is externally applied traction boundary, so outside force. So, initially we were having Nn, that is the stress by the material inside or a body, but Nn hat is applied on the body. Okay. So, we can write sigma nn hat del u naught hat sigma ns hat del us plus sigma nz hat del wz, where it will work dz and ds. So, del w naught was same. So, we have taken common. So, work is the external field, work done on the system. So, it will be negative if we consider negative work. Then similarly this will also be a negative. So, now you have un is u naught minus z times w naught comma n, and us will be u naught s minus z time w dot comma s. So, their first variation del u naught, what will be that? Put del here. Similarly, del u s will be put del here. So, we have replaced del u n by our main assumption. Similarly, del u s and del w is just del w naught. Now, again using the definition of the stress resultant. So, we will say that n hat, the resultant normal force applied will be equal to, I would like to say that in plane resultant first, in plane stress resultant. But what are these? That applied stress resultant, n hat, sigma n hat dz. Similarly, sigma ns will be sigma ns dz. So, the quantities multiplying this and this will contribute n and ns. Similarly, z time of nn will give you the applied resultant moment mnn. Similarly, mns. Now, what about sigma nzwz? So, that tells you the shear force. So, resultant of shear force applied, it will be nz dz. So, previously when we are talking about the stress resultant, in the case of internal work done, we have a contribution ns, ms, but we do not have contribution of this, because their epsilon zz was 0. So, there was no sigma nz term was there. But for higher order theories, if you talk about consideration of w is just not w naught, you take w is equal to w plus z time of something, or you say that if you are not neglecting this, then internal work done will also have a contribution of shear stresses. So, but for our present case, we have assumed epsilon zz is 0. So, in del wi, no shear stress concept, or I say that q1 and q2 no concept, but higher order theories may have this concept. So, now this our modified one. So, you see this is on the boundaries, this is on the area. So, till now we have obtained del k, we have known. Now, del wi we know and del we know. So, all the terms we have calculated. Now, we are going to put back into the Hamilton principle. This is the Hamilton principle. Substitute all the terms. So, this is the contribution due to del k. First, I will concentrate on the terms which are on the area. Then, this is the contribution due to the internal work done, and this is the contribution due to the external work done. So, these terms will be remain on the area. Now, rest of the terms comes under the boundary. So, basically this n is nothing but a contribution of non-linear terms. So, finally, using the fundamental lemma of variational principle, following set of governing equations are obtained, or sometimes we can say that Euler-Lagrange equations are obtained by setting the coefficients in area or under integration equal to 0. So, first equation, second equation and third equation, where this n contains nxx, nyy and nxy terms, basically with the del w naught something. If you see here for non-linear case, that this n contains nxx, nyy, nxy, and equation 1 and 2 also contain nxx, nxy. So, these are the coupled equations, that some of the terms are here and some of the terms are here. But without nonlinear, or I would like to say for linear case only, n term will be 0. So, equation 1 and 2, nxy is here, nxy is here, are coupled in plane mode, in plane stretching, and equation 3 is independent. If we say only for linear case, then there will be, this term will be 0. So, it will have mx, my, no contribution nx, ny. So, under the pure bending or bending case, only third equation to be solved independently. So, most of the time you will see that plate under bending or a pure bending, we solve only third equation. We are not considering these two equations. But if we say that plate is thick and we are interested to find out u naught, v naught, then we have to solve all the equation together. Now come about the arranging the boundary terms and their coefficient. You see first difference, that which is from external work done. Work done is having n hat del u naught n, this term, and this term is like this. Can we club it together or some ny? This n hat is not same. So, we cannot put these things together in this form. So, first there are two ways, either you convert this into this form or you convert this into this form. That this form is converted into a suitable, generalized, normal and shear components, and then the both of the terms will have same coefficients, and then we can club it together. This part is the very important step while developing the theory. Specifically, if we are interested to develop a generalized program or a generalized methodology, then we require these steps. If you have only just a simple problem, one specific case, then you can go for a direct substitution, like along x axis do the integration, and similarly external work done. Sometimes we do not consider that there is no externally for that equal to 0. So, only this contribution will come out. So, we are going to develop for a generalized case, later on it can be used. So, we are going to convert this thing into this. So, first of all we are going to put del u naught coefficients together, nxx nx, nxy ny, del v naught and del w naught, del w comma x, del w comma y, and the contribution from the external work done. Now, see the transformation. Let us say we have a coordinate system x1, x2, or you say that x, y or z, that this we have a coordinate system. Now, a normal another coordinate system which is making an angle theta s, and z remains r. So, along the z axis, if you rotate x, y, and it becomes n and s and r is z same. So, how to transform? This is your transformation. This is the standard, that even if you have that component x will have a component along n direction n cos theta, nx cos theta, similarly along y direction minus ny sin theta. So, you see that n as transform coordinates, our original coordinates. So, this is your transformation matrix, that how to transform from a x, y, z coordinate to normal and shear coordinate system. So, displacements. Now, so u naught, v naught, w naught can be written as nx, ny in terms of u0 n, ny, nx in terms of u0 s, and w is w naught since it is rotating about third axis, z axis. Similarly, the derivatives of w comma x, w comma y can be written like this, just 2D matrix w naught n and w naught comma s. This is the standard form. I think in second semester or third semester, if you go to a AutoCAD course or any MATLAB program, then you see that how to transform a two-dimensional or xy, just xy is this and this becomes x dash and y dash in +2 level also if this is theta. So, instead of that you are saying that cosine vector, where just cos theta is nothing but the cosine vector nx, sin theta is nothing but cosine vector ny. So, now the transformation for the stresses. I would like to say that previously this u naught, v naught are the vectors. So, in that if you remember in index form q and u dash, this was the q is your transformation matrix. Okay. Now, we are talking about the stresses. So, we will say that sigma is nothing but q sigma dash and q transpose over. So, basically sigma dash is nothing but q whatever sigma and sigma transpose. Following that way, we are expressing sigma n, sigma s. So, that is why nx square, ny square, 2nxy, this terms comes into the picture. So, if you somebody tells you what is that sigma n, and sigma n is nothing but sigma x nx square plus sigma y and y square plus sigma xy and x and y. So, corresponding n क्या होगा? Similarly, one can write it will be nxx, nx square, nyy and y square plus 2nxy, nx and y. So, you see nxx is nothing but this. Similarly, nns as per this, following this. These things are given in the book. You need not to remember that what will be my this is very easy, even you can remember this, but sometimes people get afraid, okay, this is the so big equations, how to remember all these things. These are the standard formula given in most of the theory of elasticity book, whether you talk about or specifically you go J. N. Reddy theory of plate and shell book or the theory of elasticity Martin and Saad book, there you will find the standard formula, or the mechanics of composites book, there also the formulas are given. Next, the moment will also follow the same rule. So, now you see how to convert this from nxx, nx, nxy, ny del u naught plus this thing. So, we are going to replace with it n and s, okay, and similarly this to this, okay, and then multiply it. So, what will be that? Nx nx square del u naught n. The next I would write like ny square del u naught n. Next contribution minus ny nx nxy and del u naught n, and then here will also some I just written minus things will come up there, or let me just see, yeah, here is plus. Okay. So, similarly del u n nxy n1. So, basically if you put these things together, you will get this contribution del u naught n and this contribution nxy ny square nxx nxy. So, this is nothing but the definition of nn, and this is nothing but the definition of ns. So, one can check or verify, just it is a simply expansion of del u naught and del v naught and multiplying together and taking the coefficients of del u naught and del u naught. So, you can write like this. Now, we have a terms like this. So, substitute those things here and then multiply and arrange the terms coefficients of del w naught comma n and del w naught comma x. So, you see that definition of MNN and definition of MNS. Now, finally, our constant or the coefficients are equal. Now, we can club together. So, by the system, on the system, contribution of del u naught, ns, and here they have written this term together, which is the contribution as del w naught, and this is the contribution of del w naught comma and del w naught comma s. So, here I would like to point out that till here you find that 1, 2, 3, 4, 5, there are 5 boundary conditions need to specify, you see. But on an edge, if you are talking about an edge of a plate, so how many variables can you specify? Along normal, along shear, along z direction, and one is the slope. So, basically if you talk about 4 variables maximum you can specify at one edge, one slope and 3 basic variables. They may be mixed, they may be like if you talk about all displacement u, v, w and then w comma x, that you can specify. So, if you talk about a clamped boundary condition, this is your condition. So, the Kirchhoff for the first to rectify this system. So, what is this? That is said, let us say to work with this. So, further del w naught comma s, again you do the partial integration, that first function as it is, differentiation of that and so on. So, basically this term remains on boundary and this term goes to the corner. So, I would like to put it that it will be the twice contribution, because MNS from there you will get. So, at the corners of a sharp edges you will have some shear stress MNS, MXY from that. So, whenever we develop the theory, we used to put assumption that for smooth corners, fillet, then it will not have this shear. So, this will be taken as 0 for a plate which is having a smooth corner and contributed further to the boundary conditions. So, now again defining a, so basically one contribution from comes to here. Now, you see what is this Mn, Nx, My, Mb. So, putting together we are saying, let us say this term is nothing but a Vn, shear force along normal direction or shear stress basically, Kirchhoff shear stress, we used to call it Kirchhoff shear stress, shear stress resultant along normal direction. So, all these terms plus contribution from Mns we are putting together and making is Vn. So, now our modified boundary conditions 1, 2, 3, 4. So, this concept of Vn, if you do not go through the variational principle method or energy method, then it is very hard to understand, okay, from where this contribution is coming. So, here mathematically these things are coming and we are saying that, okay, physically at the sharp corners there will be a resultant shear stress, one from, if this is a sharp corner, one from this side, one from this side. So, at this point twice of Mns will be there acting. But if you say that these corners are round, so this will not come. So, we can write in standard form Vn hat is nothing but Qnn Mns. So, U naught as W naught and W naught comma n is our primary variables. Sometimes we call is geometric boundary conditions. Or kabhi sometimes we will say that essential boundary conditions, that displacement conditions should satisfy exactly. Then the secondary variables Nn, Ns, Vn and Ms, secondary variables. So, there may be known as natural boundary conditions. In most of the literature you will find that natural boundary conditions are not satisfied exactly or the essential. So, when we talk about finite element formulation, there we say that essential conditions has to satisfy, then the safe function you chooses that they should satisfy this boundary conditions. They may not satisfy this or may be satisfying in average sense. So, these are the two primary variables, one is the geometric boundary conditions, another is the natural boundary conditions. So, if this term is equal to 0, so ideally this whole has to be 0, So, we will have a combination of this either and or concept, that either Un is 0 or Nn is 0, Us is 0 or Ns is 0, W naught is 0 or Vn is 0, W naught comma n is 0 or this is 0. So, in a particular case, if you say my normal direction is y and my shear direction is s, so Un is nothing but V naught, U0 s is nothing but U, W is W, W naught. And similarly, you can find out for a particularly what are the different variables, and Vn will be look like this, where this is the contribution due to the non-linear terms. So, if the primary variables are not specified on any portion of the boundary, then the natural boundary condition on that portion has to be specified, Nn equal to Nn hat, Ns equal to Ns. For example, if we talk about a beam, and this as is having let us say a axial force what I say P. So, I will say that n or if this direction is x. So, nx at x equal to L will be equal to P. That is the boundary condition it means. Similarly, if you applying just a shear force tau here. So, I will say that nxy will be equal to some tau applied, I always say that. Similarly, you can take a moment resultant on this edge. If this is free, so that is equal to 0. So, we are just further specifying for a free edge. It means a free edge is when where geometrically not restrained like this. A edge is free, cantilever beam, this edge is free. So, there you have to satisfy the natural boundary conditions, all these stress resultants. For the case of clamped edge, where edges are restrained, so all 3 displacements and 1 rotation, or I would like to say that slope is 0. So, basically here at y is equal to 0. So, y is your normal direction. And if you are talking about a simply supported case, people think that simply supported case is a very simple case and so on. It is not so, it is a mixed boundary condition case. Here in literature there are 2 type of cases, one is that SS1, another is that SS2. Sometimes we call this hard supported and this is called soft support. So, in the hard support, let us say this edge is my y is equal to 0. So, NYY simply supported के बाद you see first variable here NYX and here you say that W naught. So, at simply supported from the top this is clear that either W naught or Vn we are talking about some. So, deflection cannot, plate cannot deflect downward. So, W naught will be 0. And what about U naught? So, U naught, either U naught or NXY. So, in that variable we choose is plate is not allowed to move along x direction, U naught is 0 and that normal force NYY. Similarly, the normal moment. So, this is not allowing to move along x as well as along the z. Then we have a condition SS2, V naught, W naught, NXY, MYY. Similarly, since we have assumed that all our variables having time dependent, then value of displacements and their first derivative with respect to time at t equal to 0 will be like this initial conditions. Now, we are going to see that we have this set of governing equations. Can we solve directly? What are our primary variables? U naught, V naught and W naught or its variations? But the equations are in the form of Nx, Ny or Mx, My. These are not our variables. In this approach, we have assumed our U naught, V naught and W naught. If we know them, then only we can know that Nx, Ny and W. So, we cannot directly solve this set of equations. We have to convert first this set of equation using the constitutive plate relations into primary variable form. Then only we can solve it. So, what is our constitutive relations for plane stress case? Sigma xx, sigma yy, sigma xy is q11, q12 like this and some epsilon xx, epsilon yy, gamma xy, and this you may say that contribution due to thermal, due to temperature, thermal load. Further, if you say that okay, my plate is made of smart material or piezo, so you have to take consideration of piezo. This I have just for your exposure point of view, that this set of equations will remain same whether if you are talking about a developing of a classical plate theory for a piezoelectric plate or a plate under thermal loading or a plate under mechanical loading. So, this set of governing equations remains the same. But if you say that for a coupled one, that is for uncoupled, I would look say the uncoupled field, uncoupled thermal and piezo field. So, this remains same. So, changes come here only. So, while making the constitutive relations, you may consider a thermal load as well as electrical load. So, if you know that the governing set of governing equations, so you directly even those governing equations are given in the book, standard books, and for curiosity point of view or for a small project in masters or a BTech, you can just put it here some or later on some magnetic contribution or some if you want to take some porosity effect. So, just go on and on and on. So, those kind of effects you can consider at this stage. So, next for the present case, our shear stresses tau zx and tau yz are we have taken 0, but for other theories they may not be 0. So, for that case this constitutive relations will be used. Again, if we say that for a composite plate my fibers are aligned at an angle, so or my geometrical axis is not with the plate axis. So, in that case using the transformation law, that transformed reduced stiffness you will get and present like this. So, I am also putting stress here that these things need not to remember, just you say that okay, if my geometric axis is not with that plate axis, material axis is not aligned with the plate axis and it is at some angle, then we are going to use these constitutive relations. So, these are the standard relations are given in any mechanics of composite books or the theory of elasticity book. The real things comes here. What is the definition of nx, ny and yxy? So, definition is sigma xx, sigma y, sigma xy dz. So, put that constitutive relations here, okay, and do the integration 0 to minus h by 2 to plus h by 2 dz. You see the z times of something will come, but here is z, so z square. So, there will be no contribution from this side. So, that is why I have written finally it reduces to some matrix A11, A12, A16. So, we called matrix A which is known as extrational stiffness matrix, which contains epsilon xx naught, epsilon yy naught, gamma xy naught, and these are the contribution to the temperature loading. Or sometimes we call a thermal load. Similarly, the moments mx, my, mxy, moment resultant basically. So, we will say that sigma xx, sigma yy. So, again, so this having z times, so it will not contribute, only z square becomes z cube. So, this will contribute and this will contribute and this will also contribute. So, finally, one can write D11, D22, D16, D12, D22, D26 like bending stiffness coefficients. So, now we can say that what is Aij or A11, A12 in index form. In a short form we can say that Q bar Ij, Ai ke liye is to be multiplied 1, and when we are interested to find out the Dij elements, then we will put z square over this. So, finally, after the integration this term will be there. If it is a isotropic plate, so A becomes Eh by 1 minus mu square and D becomes H square by 12 into A, and that thermal load and that thermal load NT and MT contribution to the moment in the to the temperature. So, MT will be there. If it is a composite plate or a layered plate, when I am saying a composite, it means a number of layers 1, 2, 3, 4 and so on, and each layer will have a different material property. So, the basic difference comes here. When we are talking about isotropic, this is a single material, so our A becomes like this. But when we are saying it is a layered plate, then you have to take summation of this, like it says that first layer data, then second layer material property K, third layer, fourth layer up to nth layer. So, you can find out a equivalent extensional stiffness. Sometimes when we use classical plate theory to analyze a composite plate, we say that equivalent single layer plate theory. The term the equivalent comes to here, that Aij is combining of this, giving only one constant, but taking consideration of all these things. Similarly, the equivalent bending stiffness coefficients we can obtain like this. And in journal, for case of composite Q1, Q2, you know that if E1, E2, mu1, 2, mu3 are different, these are the standard relations. So, finally, for the case of a cross ply plate or a isotropic plate, or I would like to say when the material axis is aligned with the geometric axis of a plate. So, the following equation of Nx My is used. So, these are known as plate constitutive relations. So, I have arranged systematically. So, this contribution due to the linear terms, this contribution due to the non-linear terms, and this contribution due to the thermal load, and here it contains only linear part and thermal part. So, we have this first equation, or I would like to say that Nxx comma x plus Nxy comma y equal to I naught u double dot. So, you substitute this thing from here. So, it looks like that. A11 of u naught comma x, if you take derivative, second derivative, A12 v naught comma yx, second derivative, then this along x and Nxy, Axx in this, and non-linear contribution and thermal contribution and this. So, our first equation becomes like this. So, now this equation is in the form of primary variables. Similarly, the second equation can be converted into this form, and the third equation also using D11, D12. Basically, I have to put some bracket is here. So, this is your third equation. You see that second equation and third equation, if you talk about only first equation, second equation and third equation, if it consider only a linear case, for linear case, so this contribution will not be there. So, these 1 and 2 are not coupled with the third equation. So, we can solve it directly, here even this contribution will be 0. But when we have a contribution of a non-linear terms, then we have to solve all the equations together.